Hi everyone, Marco here with SkyCiv. Today I'll be showcasing the functionality of the new S3D optimizer by demonstrating how to use it on the model seen here. Note that as a prerequisite for the optimizer to run, your model must be able to be solved error-free. Let's go ahead and run the model through the solver to double check that there are no issues. It's useful to know the initial structural stability of your model as well, so solving before you run the optimizer is always a good idea. Opening the summary results to look at this model's initial displacement and stresses, we can see that span deflection, member stress, material strength, and global drift are all satisfied as their utility ratios are below 1. However, material yield has a utility ratio of 1.512, indicating that some members in the model are not structurally feasible. The good news is the S3D optimizer will not only reduce the weight of your model, but will also modify your model to ensure your design checks are met. Now let's open up the optimizer settings to prepare the optimization. You can see each valid section is loaded into the setting window and pre-selected. Deselecting a section will exclude it from the optimization, meaning the section will be unaffected and won't change. I can also click on a section in this window to open up the specific settings and controls associated with it. There are 3 main controls for each section, and leaving them blank simply turns them off. First, we have dimension limits. These are bounds on the sections, and the optimizer won't test sections that fall outside the maximum or minimum range for both height and width. Next, we have the change section control. This will test other section shapes as well as the existing section shape. As an example, we are currently testing W shapes, but suppose I wanted to test HSS. I can click on the drop-down menu and add HSS to the list. Please note, you will only be able to test shapes in the same library. As the current shape is W2448, we can only test shapes in AISC as indicated in the top right corner. Finally, we can either include or exclude different sections. Suppose I did not want to test W10 for some reason. I can simply add that to the exclusion list. On the other hand, if I only wanted to test W24, I can add these to the inclusion list. The Criteria tab allows us to create more specific design checks. We're able to set upper limits on different utilities. In the case shown here, the optimizer will return a model with utility ratios less than 0.95. Similar to the Sections tab, if we don't want to consider one of these checks, simply leave it blank. In this example, however, for the sake of simplicity, I'm going to be setting our utility ratio limits to 1. Now we can also impose absolute magnitude limits on deflections and stresses. As an example, if I were to run the optimizer, no deflection in the y direction would exceed 0.35 inches. Note we have these checks for a wide variety of stresses and deflections. Now once you're happy with your criteria in section selections, simply hit run to start the optimizer. If you direct your attention to the progress icon in the top right corner of the screen, you can see the optimizer is finding a model that satisfies the design check specified as the original model did not. You can now see the optimizer testing different models. It's important to note that the number of models tested may change from optimization to optimization. We determine an appropriate number of tests to maximize savings through the use of machine learning. This optimization will take roughly a minute, so we'll fast forward to when it's complete. Opening the results, we can get a better understanding of what the optimizer did. We can see the new model is roughly 4,000 pounds lighter, corresponding to an approximate 24% material savings. We can also see that the new model does in fact pass our design checks, is indicated by the criteria met category at the bottom of the window. We can see there were 2.4 to the 10th possible models to test, as indicated by the possible combinations row. This number is proportional to the selections on our initial sections tab in the optimizer settings. However, we only called the solver 67 times, meaning we only tested 67 models. We are able to achieve these savings even when only testing a few models through the help of our machine learning algorithm. That's going to conclude the walkthrough of the new S3D optimizer. We're excited for you to try it and would love your feedback.